All right, so 14.5, looking at difference of squares. All right. So the main thing here is that you're going to lean on this formula. The more you do it, the less it becomes a formula, and it's just something that you recognize and you implement. So it has to be difference, which is subtraction of two perfect squares. So if that's the case, notice we have here x squared minus y squared. If I can establish that I have a perfect square minus a perfect square, then whatever those square roots are, I would do plus and minus that. So notice we have x squared minus y squared. I can rewrite that factorization as x plus y times x minus y. So when I look at this example here, a squared is 8 times a, 25 is 5 times 5. So because I can break it up like that, in which I have a squared minus 5 squared, that's going to be a plus 5, a minus 5. So basically I have to look at each term. If each term is a perfect square, whatever those square roots are, I would do plus and minus both of those in the parentheses. All right. So next one, 49 s squared minus 4t to the fourth. So 49s squared is 7s squared. And then 4t to the fourth is 2t squared because we had a t to the fourth. So that's squared for the t. And since that is the case, that's why I have 7s plus 2t squared, 7s minus 2t squared. All right. All right, next one. 18wz, w squared z minus 2z. So notice the first thing I did, remember I told you, as far as factoring, you always want to factor out your GCF first, if possible. So I factored out 2z, and that leaves me with 9w squared minus 1. Nine w squared is 3w squared, and then 1 is a perfect square as well. 1 times 1 is 1. So that allows me to break it up into 2z times 3w plus 1, 3w minus 1. Any questions? Any questions? All right, now the sum of squares, in other words, if there's a plus sign in between your two perfect squares, that cannot be factored, so the result would just be prime. So remember before we had a squared minus 25 and could factor that to a plus 5, a minus 5. But if you have a squared plus 25, that's actually just prime. You cannot factor the sum of squares. All right. Here you're just re-emphasizing both of those, comparing them to each other. P squared minus 9 will break down into p plus 3, p minus 3. P squared plus 9 is just prime, cannot factor. So that's the difference between having a minus sign versus a plus sign in between your two perfect squares. All right. All right. So if I have w to the fourth minus 81, because w to the fourth is w squared squared, and 81 is 9 squared, I can break it up into w squared plus 9, w squared minus 9. W squared plus 9 cannot be factored, so I bring that down. But w squared minus 9 can be broken up into w plus 3, w minus 3. So this would be the complete factorization. All right. Any questions? Questions on difference of squares before we look at difference of cubes? All right. So difference of cubes. Here go to formulas for the difference of cubes. So if you have two perfect cubes being subtracted from each other, I'll erase these arrows, I guess. So difference, once again, talking about subtraction. If you have two perfect cubes being subtracted from each other, the formula will be x minus y times x squared plus xy plus y squared. Then if you have a plus sign between your perfect cubes, then this will be a formula, x plus y, x squared minus xy plus y squared. Now, the formulas are very similar, and notice the positioning of your x and y will be the same. It's just that you have different signs. And one way of remembering it is SOP, same, opposite, and then plus at the end. So that's why I had all these arrows there. So we're talking about this sign is the same that you originally had. This sign will be opposite, and this back sign is always positive. So you start off with the minus sign. This is the same. This is opposite. And this is always positive. Same thing happens here. This is positive, so this is going to be the same. This is opposite. And this back sign is always positive. All right. So if you want to use the difference of cubes or the sum of cubes formula, also just going back to what we established before when we talk about the squares, notice we have difference of squares. We had a formula. The sum of squares, we did not have a formula. This time we do have a formula for both sum and difference of cubes. So just throwing it out there. So looking at this first one under the cubes formula, we have w cubed plus 64. First thing you want to ask yourself, is it a perfect square? A perfect square. Is it a perfect cube? And the answer is yes, because we have w cubed plus 64. W cubed is w. 64 is 4 times 4 times 4. All right. So looking at the formula for the sum of cubes, that means I'm going to take w, plug it in where I see x, take the 4, plug it in where I see y into the formula. And that's what we did right. Oh, still have my eraser on. That's what we did right here. I plugged w in where I saw x in the formula, plug 4 in where I saw y. And then I simplified it as much as possible. That'll be w plus 4w squared minus 4w plus 16 because of 4 squared in back. All right, questions. All right, let's try it again. This time the difference of cubes. So we have 27p cubed minus 1000 q cubed. So 27p cubed is going to be 3p. Cube root of that would be 3p. Cube root of 1000 q cubed is 10q. 27 is 3 times 3 times 3, 1000, 10 times 10 times 10. So it means I will plug in 3p where I see x, plug in 10q where I see y. All right, and so 3p minus 10q will stay the same. Be careful here because this square needs to multiply to both terms or both pieces of your term. So that should be 9p squared. So a lot of times people will give that square to the p and forget to give it to the 3. Then here, 3 times 10 is 30 pq. And then the same thing happens here. 10 squared is 100. Then you have q squared. Any questions? All right. 125a cubed plus 1. Same thing. Establish what the cube roots are. So 125a cubed is 5a. 1 is a perfect cube. 1 times 1 times 1 is 1. All right. All right, so 5a goes where x is, 1 goes where y is into the formula. So that's 5a plus 1. 5a squared is 25a squared. 5a times 1 is 5a, and then 1 squared is 1. So that would be a factorization. Any questions? All right. So the next one we have 4x cubed plus 4x squared minus 25x minus 25. All right. And so here we want to factor by grouping because we have 4 terms. And here just making sure we're careful because that negative needs to be included with the 25. So that's why we have 4x cubed plus 4x squared in one parentheses, negative 25x minus 25 in the second set of parentheses. Factor out the GCF of 4x squared. Factor out the GCF of negative 25. That leaves us with x plus 1 in each parentheses. Bring it out front, and what's left in your parentheses is the x squared minus 25. And you always want to factor completely, and we see that second set of parentheses is a difference of squares. 4x squared is 2x squared, and 25 is 5 squared. So that breaks down to 2x plus 5, 2x minus 5. Make sure we're okay. All right. We talked about perfect square trinomials last class. Questions, questions, questions. All right. So, as always, you have to try the stuff out to see if you have any real issues with it. And if so, make sure you get with me. Let me see. Somebody that emailed me. Oh, yeah, an email. And yeah, and that's it. That's really actually two sections. That's actually 14.5 and 14.6. They talk about the difference of squares and the sum of difference of cubes. Next class will be a review day. We're almost done with chapter 14. Not quite done yet, but I'll leave Friday for a review day. So it's up to you. If you have any questions, I'll be there to answer them. If not, then have a great weekend, and I'll see you on Monday. You don't necessarily have to show. It's up to you, but I will be here on Friday at 3. If anyone has any questions that they want to, get help on, any problems they want to get help on as far as, the problems that we have had assigned. So, yep. So, but if you're good to go, you don't necessarily have to show. It's up to you, but I will be here. All right. Questions? Any questions, concerns, comments before we close? All right. Well, you guys have a good one. Be safe, and I will see you on next class. Oh, I had somebody. Let me hit the start the record.